Okay, hello, period four. I just wanted to apologize. For some reason, everything that keeps happening happens on A days and in the afternoon. So this is the only class that I've missed like this. I haven't missed a B day yet. So I apologize for that. So this is the first page of chapter 2. I'm just going to review some of the stuff we talked about last year. Elements build molecules, molecules build cells, blah, blah, blah. Tissues, organs, systems, organism. And it's important that we get down to this level, the elements in the molecules, so that you understand some of the things that can happen with a very simple problem with just elements, like not getting certain elements that you're supposed to have in your body or certain molecules that you're supposed to have in your body, and some of the symptoms that come about because of that. So we know that an element, and you can also like call that a molecule, well, sorry, not a molecule, an atom. I don't know if you remember this from last year. It is the most basic substance. So if you look at that picture of the periodic table, it's a little blurry for me. These are all the periodic table of elements that we have on the planet. This is the stuff that builds the whole universe. You've heard of some of them: hydrogen, carbon, nitrogen, oxygen, helium, you've probably heard on, neon, argon. And then there's things like gold, iron, copper, all sorts of stuff is in here. Sodium, potassium. Potassium is with a K. And these atoms, I'm going to use the examples Na, that's sodium, and Cl. That is an element called chloride. So an example of an element might be sodium, or chloride. Those are elements. And an atom of that element is something like this. Like the element is carbon, and if you have one of them, you have an atom of carbon. If you have two or more elements glued together, you get a molecule. Okay, so in this case, I'm going to show you these two actually, sodium and chloride. They actually glue together beautifully, and in a second I'm going to show you why. But if I put sodium first and then chloride, that's actually just salt. That's table salt that you sprinkle all over your food. I took this element and that element, and if you glue them together, you get a molecule. And the question is like, why are these things gluing together? And this is super important. You're going to learn this in the 7th grade in chemistry. So first I need you to know what an atom looks like. There's a picture up here. There are 3 parts to an atom. There's a proton, which is positively charged. And this is like electricity, which is super important. There's a neutron, which is neutral. It has no charge. And then there are electrons, which are negative. So the number of positive protons should equal the number of negative electrons for this thing to be balanced and happy and chill. And it comes in like what we call clouds. That's a cloud, and so on. And depending on how many protons and how many electrons it has, that changes the element. So for example, helium only has 1 proton and it has 1 electron. And in the first cloud, every single element wants 2. And every cloud after that, it wants 8. So for example, carbon only has 4 out here. It needs 4 more electrons to feel happy and kind of like stable. So I'm going to draw the first one because that was a little confusing what I just said. Let's do hydrogen. Hydrogen in the center has a proton, and in that very first cloud, it has one electron, and that electron moves. It travels in a circle around the center of the atom. If I go up on my periodic table, and you always go across, so from this row over here, helium. Helium has 2 protons, 2 neutrons. The neutrons don't really matter. And it has 2 electrons. And in that first cloud, it always wants 2 only, just in the first cloud. Every cloud after that, it wants 8. So this is happy and balanced. This one, not so much, because it doesn't have 2. So if you think about hydrogen, hydrogen doesn't like that it just has 1 electron right here. It either wants 2 or it wants none. Helium is happy. It has 2 electrons. It doesn't need to do anything else. I'm going to go up another step. So I went here to here, and then I'm going to go to my next row. And it looks weird that there's a big space here, but there's a reason for that. We're going to go to this one, and we could keep going if we wanted. Lithium. Lithium has 3 protons, 3 neutrons. In its first cloud, it has 2 electrons. But it has a third one now. Floating out here. It wants 8 in this outer shell. So if the atom gets a full outer shell, it's very happy and it doesn't react well with other things. It's very stable. So like helium is super stable. The first cloud wants 2 and it has 2. Hydrogen is not so stable. It wants 2 and it has 1. So it's either going to need to gather another electron or it's going to give this electron away. So I think about, when I think about this, these become negatively or positively charged. So for hydrogen, it wants to give this electron away because it doesn't like just having 1. It's in a bad mood if it has to do just 1. And this is very negative. It's like negative energy. And I imagine this is when I give away my negative energy, like if it gives it away, I would feel more positive because I've given it away. So hydrogen, because it gives this away, ends up being positively charged because it has a proton, but it gave its electron away. So anytime you give away negative energy, like you vent and you tell someone how angry you are, you feel better. That's kind of how hydrogen is. It's positively charged because it always gives this away. It doesn't like that it just has 1. It has to have 2. Similarly, if I look at one of these elements over here, these all have 8 in that outer ring, but these don't. These have 7. And they want 1 electron. So let me see if I can come up with an example of this. Salt. Sodium has a positive charge because it had in its outer ring only 1 electron, and it gives it away. When it gives that electron away, it's left with an extra proton. Chlorine has the opposite problem. It's negatively charged because when you look at chlorine, it has all these positives in here. The first electron cloud has 2. The next electron cloud, chlorine, has 8. It has another cloud after that where it has 7. And it's missing 1. Where does it get it? It gets it from this guy. This guy had an extra 1. So sodium gives this electron to chloride, and this becomes more positive because it gave its negativity away. This becomes more negative because it was the friend that was a good listener and took all this person's problems on to their own soul, and now they feel sad because they took on their negativity. And this guy feels better because he gave his negativity away. Ha! All right, so anyway, this is positively charged, this is negatively charged, and when they are charged like that, we call them ions. So down here, an ion. An ion just means it's charged, like hydrogen is positively charged. Chlorine is negatively charged because it took on somebody's negativity. Sodium is positively charged because it gave away its negativity, its little electrons, and now it feels better. So an atom or group of atoms that have lost or gained an electron. It either gives it a positive charge, like hydrogen, or a negative charge, like chlorine, for example. And again, hydrogen is positive because it gave an electron away, taking away the negativity, so it's happier. Chlorine is negative because it took negativity on and it took on an electron. It grabbed one. Okay, so what does this have to do with medical science? We're going to be talking a little bit about these elements that you need in your body. You have to have some of these or you'll have huge problems. For example, iron is on here. And iron, if you run out of iron, you have huge problems in your body. You're anemic is a problem that you would have. You would feel tired all the time. You're not able to get oxygen to your cells. There's a lot of stuff you need iron for. Iron is that metally taste in your blood. So if you bite your tongue and you taste blood, it's kind of a metally taste, and that's because iron is in your blood. So first, we're going to talk about electrolytes. If you've ever exercised or heard about people who are exercising, they say you have to drink your electrolytes. Gatorade has electrolytes. Electrolytes are just charged ions. That's all they are. Like sodium or potassium or chloride. All of these are electrolytes. They actually help your nervous system. Your muscles, including your heart. No potassium, your heart doesn't beat correctly. And all of the balance of your fluids. Fluid balance. And next class, we're going to do an acids and base lab. So acids and bases are types of electrolytes. Remember, these are just charged ions. They're either positive or negative, and this is actual electricity. This is why getting electrocuted is bad, because all of your atoms in your body are charged. And they are electrolytes because they do actually conduct electricity. They can break down in water. And acids, and this is super important, acids, like hydrogen, they can release, so chemicals that are acidic, they can release hydrogen ions. We'll taste one next class. They tend to be sour. And you've tasted lots of different acids in your life, but I don't want to give you any because we're about to do a lab where you might taste some stuff. By the way, you don't taste all the acids. You just taste a few of them. Other ones would make you very sick. A base accepts hydrogen ions. Usually you'll see an OH in the equation. And they tend to be bitter. They tend to be slippery when you touch them. Like soap. Soap is very basic. Acid, soda, orange juice is acidic. All right. So what you have is you have this page, and you are going to look on Schoology. It tells you trace elements. There's 1, 2, 3, 4, 5, 6, 7 maybe. And you're going to be taking some notes. What's the name of the element? For example, iron. How much are you supposed to eat every day? What body activities does it help you do? So like iron, it might be all your muscle activities. If you don't have enough of it, what happens to you? What's a symptom if you don't have enough iron? And I want to know what food you can eat to get that iron. So if you don't have enough iron, the doctor would tell you that you're anemic, and maybe they would tell you to eat red meat or to eat broccoli or to take an iron vitamin. So you're going to do this chart, which is the main elements that your body needs to function. And this is on the Schoology. The chart is on Schoology. It says trace elements. And you can fill this out from there. And the sub should have this for you, so you can fill it out. Okay, so that's item number 1 that you'll do. And then the second thing you're going to do is read about something called acidosis. And that is basically when your body becomes acidic. You'll read an article and you'll answer the questions. And again, that also is on Schoology. Both those things you should try to get done today in class. And then on Thursday, we will look at acids and bases and hopefully get to our acid and base lab, which is kind of fun. All right, good luck to you guys. Thanks.